Welcome to Projects for All. My name's Mike, and today FindBuyTool has sent down the latest version of their wood planer. About $700 at the moment on the website. We already did this planer, essentially, but this is the newer version, and it has the gauge on the front to measure depth of cut before you run your wood through it that I complained about in the first video. So let's get it out. This is going to give us a second chance to check out the quality of this planer with a second unit. We still have the first one, and we can look at that too if we have to. So we'll get out of the box, we'll have a quick look at it, and we'll run some wood through it and see how it does. A few specs on the box here. At least 50% lower noise than a traditional plane. I don't remember if we sound tested it. We probably did, which is silly with a wood planer. You need hearing protection regardless. 40 replacement carbide inserts. 27.5 feet per minute feed rate, motor overload protection, 10,000 RPM speed. We might be a little brief in this one because essentially I believe this is going to be pretty similar, if not almost the same, to the one we already did. We're going to definitely see if the quality is the same and if it works just as good as the last one, because the last one I was pretty impressed for a budget wood planer. It definitely planed well, which is all you really needed to do. Just make this easy on myself. These things are heavy. Have to push that out the back, I guess. Parts list reprinted on the box. That's nice. Dust port. We can neck down from 4 inches to 2.5. Got our hand crank. Not bad T-handles. Torx. Comes with 5 replacement cutter heads. There's no assembly with these. We just got a screw on our crank. Just a Phillips head machine screw, and then we'll put our dust port on the back and we'll have a quick look and see if we see anything new with this one versus the old one, but I think we're going to find they're very, very similar. We got our inspection cover here for our cutter head. So let's pull this off before we put our dust collector on here. Just thumb screws, real simple. Plastic cover, comes right off of there. Port for the cooling fan for the motor, right there. And there's our cutter head. Beautiful cutter head. Dust port. Just basic plastic, but screws on the bottom, hooks on the top. Just hooks right on this plastic cover right here. We got 2 screws underneath, and that's installed. And that's it. All right, we'll start on the top here, like we always do. We've got a few blemishes in the finish on this one. There's one there. And there's one there towards the back, but in general, it's a good looking machine. The powder coat has metallic finish, it looks nice, but this one's got a few marks on it. Don't know why. I don't believe I remember the other one having that. One rotation is a 16th. You got a quarter turn is 1/64th, then you got 1/32nd, 3/64ths, and then all the way around for a 16th. This is the carriage locking handle. Pulling this towards you pushes these rubber feet into the poles that it rides on. It does this in all 4 corners. There's one here. It's a little hard to see because they're black, but there's one in the back for each corner. Pulling this is pretty stiff. There you go, locked. Releasing it, very stiff, but I would rather have it require a little bit of extra effort to lock it and stay secure than to be easy to move this handle and it not being completely locked. Working from left to right, we have our depth stop. This block here is from 1 inch in quarter-inch increments on the scale here, and you can push this down and you can just see on the corner here, it's going to contact that bolt right here. There's a jam nut on that, so you can adjust it. I said this in the first video, and this is the same design. Do not pull this out of here. You can pull it straight up out of there or push it down all the way through, but there is a little spring and a detent ball that rides along the edge here, and it's in here, and it's a pain in the neck to get back in there if you let that come out. I screwed that up in the last video. It took me about half an hour to put it back together. So you get your power switch. There's on, there's off. There's a little plastic key. You can pull that out of there. So if you're going to put this in a school or you have an orange cat at home that you cannot trust, you can take that out and disable this. There's our motor reset button. Here's where the brushes are. There's one obviously on the corresponding opposite side. Model FTB131H. 6 inches max stock thickness. 13 inches, obviously, from side to side. We have our ruler here, both in inches and in millimeters. This is the jam nut and bolt. You can adjust the height of these on all four corners for the two tables, but I don't think we have to mess with this one, which makes me happy because I spent a good amount of time fooling around with the last one. The button for this depth indicator is right here. So you can put a board in here and lower the carriage down onto the board to your desired amount of material you want to remove, and then run it through. I have it where it's just about to move. It's on 0, but if I crank it down, it's going to move. I'm going to do one full revolution. And are we on a 16th? Not quite. One full revolution of the crank in the top should be 1/16th, but that's not what I registered with this. We're a little bit short there, just a little tiny bit. You can also work in millimeters, 0 to 3 millimeters. We'll set this right on 1 millimeter. So we got 19.2 millimeters on this board. 19.22. The other side, 19.42. 19.32. All right, well, we're gonna run this through. I'm gonna try and take 1 millimeter off per that scale. I'm not gonna touch the height now. In fact, just lock it now. Double check we're on 1 millimeter. All right, 1 millimeter. Exactly per the gauge right there. Let's run this board through and see if we get a millimeter off. .55. Not quite a millimeter. Close, maybe like 3/4 of a millimeter we got off of there. And this is still registering. So not 100% accurate on this. This still shows that we have a little ways to go. That should be at 0. And I have not moved the carriage, obviously. Yeah, about what, 0.2 of a millimeter, shy of a millimeter. We'll run it through again without adjusting it. Let's see if it takes anything else off. I'm sure it won't, but maybe it moved. That little bit of difference in that 0.2 of a millimeter, I think, is in the table itself. A little bit of flex in the table and a little bit of height difference between the table and the main table inside underneath the carriage there. Like I said, this is up a little bit, and I said that was probably good. I think that's affecting that 0.2 of a millimeter. We'll see. Let's try and compensate for it just for fun. It's almost 1.5 millimeters. Let's see if we can't get a millimeter off. We're at, call it 18.6. So we're not at 0 again. Yeah, I got closer. 17.78, sort of closer. The finish on this is outstanding. You can probably hear the difference in finish. It really does put a beautiful, smooth finish. You almost don't have to sand this. These cutter heads are sharp. Here's the unplaned side. You can see the difference. Maybe it's the mirror finish on this messing with my eye. But that's 16 thou, which is 0.4 of a millimeter. So the table is up probably 0.5 millimeter over the main table inside here. And that is messing with this, I'm sure. Let me see if I can't lower the table down a little bit. Maybe I can get it so it's closer to the same level and sitting flush with this. And maybe we'll get a better result. We'll try that just for fun. These bolts here are 10 mil. I'm not gonna bore you with this because it's pretty boring, but yeah, and just like the last one, these are locked together. We find another 10 millimeter wrench. I was hoping by adjusting the table down, I could lower this side of it just slightly before I made it all out of whack, which is what I have done, obviously. But we are still 16 thou difference, and that is still messing with our gauge a little bit. I was able to pop this cover off, and you can see in here, I was wondering if maybe there was a way to adjust this so compensate for that a little bit, you know. And I don't see a way to adjust this. It is this metal button here, fits in the teeth on the pointer, spring loaded at the top. Not a bad design, works fine. But I think the difference in height here between the table and the machine itself is messing with this gauge a little. I am gonna say, now that I know that we're off about 1/2 millimeter, I can just compensate for it when I set this. And I imagine using it over, you know, a good amount of time, and you'll know exactly where your actual measurement's gonna hit on this. I would probably put a piece of tape on it and just mark it myself. All right, so I hope you guys can see this. 4550 or so, just a hair under 45.5 millimeters from the bottom of this to the top surface here. So that was 45.5. We'll set this to 44.5 or close to it. Now I locked it. I have to offset it a little bit because that pin sticks up there, so I have to go to the side of the pin, so we're not 100% accurate, but I'll get it as close as I can, and there you go. It is locked, it's holding the gauge, I'm not touching this anymore, and it is right at basically 1 millimeter. The gauge is accurate, it's the table that's screwing it up. To get this perfect, we would have to figure out a way to get the surface of this table a little bit lower, and I'm not 100% sure how I would do that. Let me take the table off just for fun and let me look at how it's put together. Well, there's the bolt I took out from this side. All the bolt does is installs in the frame here, and then the table just sits on it. If I really wanted that gauge to work perfect, I would take a file and elongate this hole ever so slightly at the top, probably about 1/2 millimeter, and the table would sit about 1/2 millimeter lower, and our gauge would be accurate. All right, well, I just proved to you that I'm not an engineer, but you guys might be, so, you know, feel free to speak up. Because it rests on this bolt, which sits here on the outside of the pin that it pivots on, the pressure of the outside of the table pushing down pulls it up, off, and it sits at the bottom. I don't know if you can see. Basically at rest, it's sitting with the pin pressed against the bottom of the hole, as evidenced by, if I press down, now it's sitting on the part where I filed, and now it's pretty darn flat. So if I put my straight edge back here and I push down, now we've made an improvement. But as soon as I don't put pressure on this, we're back to at least a 1/16 off. So we tried. Honestly, finally, it only took me a few minutes. If you want to use that gauge, you're going to have to mark it and figure out where your accurate lines are. So you guys tell me in the comments, what do you think about these machines? I kept this one because it's lighter than my DeWalt. When you carry it, you're holding it closer to your body, and it's just easier to move. I love the DeWalt, but this form factor is a little bit easier to move around the shop. Since I keep them on a shelf, I will probably keep this one now because of the gauge. Even though the gauge isn't 100% accurate, I will put painter's tape on there and I'll mark the measurements myself and use it that way. It'll be totally fine. I liked having the gauge on it. But you guys tell me, is this something you would buy? The helical cutter heads on these cut like butter, and they leave an almost sanded finish. It's very impressive. I think they're still a good value. $700 at the moment for this one. I'll leave links below. You can check it out for yourself. Tell me if this is something you would be interested in buying or what you would buy. Hit me up in the comments. I'll see you in the next video.